Hey everybody, we're going to learn about monomials today. We're going to be multiplying them. We'll divide another day, okay? But we're going to be multiplying them. But what exactly is a monomial? Oh, I gotta get that out there. Okay, so monomial is it's a number, like 80. It's a variable, like x. It is also a product of a number and a variable. It does not have any functions in it other than when you're multiplying a variable and a number together. Okay? It does not ever have a plus or a minus in it. Okay? So it doesn't have any of those type of operations. If it's got a division in it, it's not a monomial either. It's a combination of them. So let's back up here for a second and let's talk about something that's really exciting. Okay, so now we know what a monomial is. So now we're going to talk about how we multiply them. Okay, how we multiply them. So this right here is a monomial, that one's a monomial. And so when you go and multiply them, let's look at this. We can actually notice that 10 to the first power is just a 10. And 10 to the third power is 3 of those. They've all got the same exact basis, and that's really, really, really important for us to recognize. They have the same exact base, and so that means that when you've got all these, now you've got 4 of them. So your answer is going to be 10 to the 4th power. So really, what's exciting about this is that you could go and cover that up. Okay? If you go and cover that up, oh, I hate all those little dashes in there. Let me get rid of that. Okay, if you go and cover that up, look at that. You could see that 10 to the first power times 10 to the third really equals 10 to the fourth. So what did I do there? What could be a shortcut? Well, I'll tell you this. We'll take 10 to the first power and we'll add it to the third power. And what are we going to get? 10 to the 4th power. Okay, so 10 to the 4th power. So if you kind of think about that, you're multiplying this, and then you go and tilt that sign to where it's going to be an addition sign. Maybe that's one way to look at it, okay? Okay, so we don't ever multiply the numbers up here when we're multiplying. We just add them. Okay, so let's go ahead and see what the law is for this, the property. Okay, they're telling me that if you have some kind of variable, okay, and this raises some certain power, they're going to call it m, and you multiply that same base variable to another type of power, what do? You just add them up. Okay, so here's a good example. 2 to the 4th power times 2 to the 3rd power, and what we're going to do, we're going to add those two variables up. There's our teacher talk right there, and you'll get 2 to the 7th power. 2 to the 7th power. Okay, let's practice some of these. So right here we've got find each product. Okay, so we've got the same base, so that's what's the important part. So it's the same base, and so we're just going to go 4 to the 3 plus 5. That's really what's happening up there. And so that's going to equal 4 to the 8th power. Now it says use this, express this with a positive exponent. We got it right there, positive 8. Okay, now look at this one. Now we're going to throw in some different kind of integers in there. So let's look at that. We've got 6 to the 1 power, because that's 1, right? That's a 1 understood. 1 plus a negative 4. Okay, remember when we got opposite sides? Because here's those integers. They keep on coming back. Got to learn those, babies. We've got more negatives than we do positives here. In fact, we have 3 more negatives, don't we? Okay, so it's going to be 6 to the negative 3rd power. And it wants positive exponents, so we're going to do 1 over 6 to the 3rd power. So we're kind of taking some of that information from the last section, and we're applying it here too. Do you notice we keep on applying them? So, I mean, if you're thinking like, gee, I got rid of integers so I can move on now and be happy in life. No, we've got to learn them because they keep on popping back up. Okay. I wanted to look at this one more way here, and so let's go ahead and look at that. What is 6 to the 1st power equal? It equals 6, right, to the 1st power, right? Okay, what does 6 to the negative 4 power equal? That equals 1 over 6 to the 4th. Okay, so it's just another way of looking at it. I myself think it looks easier if you just did the exponents, but hey, let's go ahead and multiply these. And when we do that, we'll get 6 over 6 times 6 times 6 times 6. And you can go and reduce some of those, right? And you could see that that'd be 1 over 6 to the third power. Okay, that's the one way of looking at it. But I'm telling you, I would just go with those integers instead of trying to avoid them. Okay, so let's look at these two down here. These are you try it, so I want you to pause it right now, and I want you to do 1A and 1B. Okay, so we're going to get 5. We add the 2 to the 3, so it's going to be just 2 plus 3, so it's going to be just to the 5th power. Okay, so let's go ahead and look at this one. We've got 12 to the 3 plus a negative 2. Okay, so we've got 2 negatives, 3 positives. We've got 1 more positive than we do negatives, right? Or else you could realize, again, with our integers, different signs, subtract, what's the difference of those two, and then take the sign of the largest one. Or, like we were talking about before, so that's just 12 to the 1st power, or 12. Either one of these is just fine, okay? Next. Okay, so again, we're finding each product again, and we want those positive exponents. And so this is pretty nice. This is b, and it's going to be 2 plus 2. So that's going to be b to the 4th power. Okay, now we've got, and I'd still avoid those. If you're avoiding integers, you can do that other thing I did on the other page, but I recommend you don't. Okay, t equals, the top here is going to be negative 5 plus 3. And so we've got 2 more negatives than we do positives, right? So it's going to be t to the negative 2. We need a positive exponent, so we're going to make that 1 over t squared. Okay. You try it. We've got a couple here that I'd like you to try. And let's go ahead and look at, these really aren't a whole lot different from the ones in example 1. They just have variables here instead of numbers. They've got the same exact identical base. This is pretty nice. You can see that this is a to the 13th power because you just got to add those together. So I would like you to do these two for me, please. So pause it right now. Okay, I want you to report this as one of your Q2s tomorrow at the beginning of class. And so this one right here, you'll show me the answer to that one. And then then this one is going to be x, and it's got negative 6 plus 2. And so we've got how many more negatives than we do positives? We've got 4 more negatives than we do positives, so it's going to be negative 4. Okay, now what they've done is that they have, oopsie, how did I lose that other thing? Anyways, now what they've done is that they have taken your variables with the same base, and they have added a coefficient on the front or a number on the front. These are still monomials. This is a monomial, and because there's no adding, addition, or subtraction in it. Okay, so we're going to multiply these. So we'll be multiplying the numbers. Okay, and that's going to be 16. And then we'll also multiply the x's together. Okay, and that's going to be x, and what is that going to be? That's going to be a 3 plus 4 up there. So let's go ahead and simplify that a little bit more. It's going to be 16x to the 7th. Not so bad, is it? You just got to remember that you take the numbers separately from the variables. Okay, so let's go ahead and do this one next here. So we've got the negative 3 times 2 is going to be negative because there's 2 negatives. There's 1 negative, so an odd number of negatives means it's negative. And then we got 3 times 2, so that's negative 6. Okay, times, I'm just still thinking here. We've got n, and it's a negative 9, and it's multiplying, so it's still addition, and 8. Okay, so let's go and clean that up. We've got negative 6n, and this has got 1 more negative than it has a positive. Okay, We're not done yet because, again, it wants a positive exponent. Now, this one could be a little bit troublesome to see. Do you recognize that this right here, that this -1 goes to that n? Well, it doesn't go to that 6. That 6 has got a 1 understood right there. So we'll go ahead and put this baby below. Okay, so it's still got -6 over n to the first power, and we don't write that. So how would you have been on that one? Would you recognize that -1, of course, goes down below with that same exponent? It's just now it's positive. Okay, so let's go ahead and you try it here. We got a couple more. I'm going to do another one here. And let's do 3b. 3b has got, so we take this 6 times the 2, right? I'm going to do a little more teacher talk with this one. We got 6 times 2, that's just the numbers. Okay, and then now we'll also look at the variables. We got b to the -4 times b squared. Maybe it helps if I separate it like that. I kind of separated this one up here, but with arrows. So let's go ahead and look at this. So we've got 12 times b, and then this guy right here is a -4 plus 2 because we're multiplying, we have to add them. Okay, but we still have to clean this up a little bit more. I've got -4, so I got more negatives. How many more negatives do I have than of positives? 2 more negatives. So this is going to be 12b to the -2. And this is like that one up above. We got to be careful with it. Let me extend this here. And so this, okay, so this is 12 to the first power. This is b to the -2 power. So that b is going to have to go below. So we'll go ahead and do that. So we got 12 on top, and then b will go downstairs. And just think about this. B to the -2 equals 1 over b squared. So that b squared will go down here. Okay, just think about that for a second. Or else you could even break it down even one more step from that. Okay, you have 12 over 1 times 1 over b squared. And that's how you got that, in case I skipped a step there that made it a little bit difficult to understand. So when you get those negative exponents on the variables, it feels somewhat troublesome, doesn't it? Well, I'd like you to pause the video now and do these 3 quickly, please. Okay, what did you get for this one? Did you get -15a to the 6th power? Okay, and this one right here, did you get 50, it's a positive 50, n to the 9th power? This one's going to be one of your Q2s. And so be ready to have that answer for us at the beginning of class tomorrow. Okay, so I'm sure that you probably have some questions for me about this lesson, and that is great. So let's address those questions right away at the class tomorrow. Write them down in your notes, but don't forget to have these two Q2s ready to roll tomorrow, okay? And we'll do that to take attendance right away at the start of class tomorrow. Okay, see you tomorrow.